Alright, this video is going to be about ray diagrams for lenses. Right here, again, I'm using a applet that kind of helps us with figuring out where stuff is here. If I put my object right here at the radius of this particular lens, or 2 times the focal length, there are 3 rays that are drawn in this applet. Okay, the first one is drawn parallel to the principal axes, and it is focused through the focal or focal point behind the lens. Okay. The second one is drawn from the object through the focal point on the same side as the lens, and then once it hits the lens, it gets refracted parallel to the principal axis. And then the last one is drawn directly through the middle of the lens, and it doesn't change directions at all. Okay, so what you'll notice here is that when I'm at a far away spot on this lens, or away from this lens, the image starts off small and inverted. And as we get closer and closer and closer and closer and closer, once we hit the radius of the lens, it is the same size, directly flipped upside down. And then as I get closer to the middle here, it gets really, really big, or as I get closer to the focal length here, it gets really, really big and inverted. And then as soon as I hit the focal length, okay, technically I wouldn't form any image whatsoever. As I pass that point, okay, you'll notice that the refracted rays here are getting further apart. Therefore, the extensions of those rays will form an image on the back side, or on the same side as the object. So this is a situation where we had a real image for a while, and then once you got inside of the focal point, we got a virtual image on the same side as the object. Okay, so converging lenses can produce both real and virtual images depending on where the object is relative to it. Okay. All right, so now let's go ahead and take a look at a diverging lens. Okay. If you look at the diverging lens, again, there are 3 rays that are drawn. The first ray drawn from the object is parallel, and then once it strikes the lens, it diverges out along a line that goes through the focal length on the same side as the object. Okay. The second ray travels towards the focal length on the opposite side, so it's aimed to go over here. Okay, once it strikes, it goes parallel, and then we extend that ray backwards, and then the last ray travels through the center and never changes directions. Okay, so where we get all of these to line up, okay, all 3 of those, and by the way, the first 2 are the ones that are extensions backwards. That's where our image is. So again, you're going to notice here, as far as we are far away, we have a upright image that is much smaller and is virtual. And as we get closer and closer and closer and closer and closer, it gets a little bit bigger, 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 until you strike the lens, and then we'd be on the other side, and it would just be as if you're looking through the other side of the lens. But so in this case, it's always upright, and it's always virtual. Okay, so for a diverging lens, we always have upright virtual images.